Right, so welcome everyone to the 12th lecture, I believe. This module mein what are we doing? Signal basics, system basics, 2 modules done. Yes, we are in the third one. What's that about? Kahan hai hum? Discrete time, signals and systems in time domain. Yes. So in that we were at the stage of answering a very important question. Yes, kya tha question?
Arbitrary systems.
Right. So there are many ways of posing it. One dramatic way of is to say how to tell the response of an arbitrary system to an arbitrary signal. Yeah. So we could make that less dramatic and say, okay, how do we write a formula or function for this guy if we know, if we are given the input, okay, and some properties of the input of the system, but not the actual full physics or all that of the system, right? So we don't want to go into differential equations or all that. So what kind of information do I need for this system, yeah, which can be any system, to be able to model its output knowing the input? Yeah, so arbitrary input, but of course you have to tell me what the input is. Yeah, so I have to write some formula here. That is the question we have been trying to answer, and to help us answer this, we decided to what? Divide and conquer. So we said, okay, this class of systems, since we are not saying this is a system from physics, biology, physiology, stock, economics, econometrics, anything, that means this is huge. The answer would be not so easy. Yeah. So we did what? We divided our problem into smaller parts. So kya tha subgroup? LTI. Yes. So we said, okay, we'll focus on LTI. And I mentioned last time, this is by no means a restriction. This is a huge class, and this in it is also a huge class. Yeah. And I've also mentioned many times, but it's good to repeat. Many of the tools we develop here can be locally applied to nonlinear and time-varying systems. So there is a bigger class here of nonlinear and time-varying systems to which these solutions can be adapted. Okay, piecewise apply हो जाते हैं. So then whatever you develop is actually being used for nonlinear systems. But then there are highly nonlinear and highly time-varying systems where it becomes mostly useless. उसके लिए फिर you have to take PhD courses. Okay, in the field. Okay. So, but if you understand this, those would also make some sense to me. हमला तो नहीं लगा? नहीं. Okay. इतना मुश्किल टॉपिक तो नहीं है. वो मेरा एक दोस्त है ना, यहाँ पे जेके में था, उसकी FSC थी, FC कॉलेज लाहौर से ना, तो वो टाइम ऐसे थे जब कॉलेजेस जो गवर्नमेंट के स्पेशली उनमें पार्टीज का वो होता था, कोई इस्लाम पार्टी, PSF, जमात इस्लामी, वो तो वो कहते थे जब ग्रुप्स होते थे, जब बोर हो रहे होते हैं ना, लेक्चर पसंद नहीं आता था, तो पीछे से एक जमात का बंदा नारा लगाता था, नारा ए तकबीर, अल्लाह अकबर करके सारे बात भाग जाते. So I hope that won't happen.
ये आपने अच्छी टेक्निक बताई.
टेक्निक बताई है ना, आप देखें, आप परेशान हो रहे थे, आप अब मैंने ऑन द रिकॉर्ड आपको एक टेक्निक बताया. ठीक, अच्छा. So LTI, we restricted ourselves to LTI. Then what did we do last time? Most of the lecture was on identifying LTI. Right? So we we paused our question for a while last time, and we said, okay, if we say we are going to work with LTI, we should be able to identify LTI. तो उसके लिए हमने कुछ examples की, और आपके assignment में भी है, many questions there. Is the system linear? इससे पहले what were you checking? Is the system invertible, stable, right? Now we added this one already, but then we made it more formal. So this is a very important test that we need to do before we go to this. So now the question reduced to, how do you tell the output of an arbitrary LTI system to an arbitrary input. Yeah. So this now is LTI. You have established in some way that you are working with LTI system. And then we want to answer this. So I said the second thing, first thing was divide and conquer. Yeah. So we restricted ourselves to LTI. This had to do with system. Yes. Now the second observation or the smart thing or the reason we actually may have the delta function is dividing is about the signal now, the input signal this time. Okay, and that is, what did I say about this? It was any discrete time signal, let's say xn, can be written as a sum of scaled and shifted impulses or delta functions. I rarely write full sentences on the board, सामने है, लेकिन ये this is very important. Yeah, एक मैंने इससे पहले लिखा था, how do you tell the output of an arbitrary system to an arbitrary input? Yeah, now this one. The claim, this was something to do with the systems. Yeah, then we have something that has an important implication for the signal, which is the input. Together they will answer this guy. Yeah, so what is it? Let's see. We are saying that we can write any discrete time signal xn as a, okay, let's see that, how is that possible. Last time I gave you some idea, but you can see. So firstly, what is an impulse function in discrete time? It's very simple, yeah. Integration वगैरह कोई नहीं है, बहुत simple हो जाता है. Yeah. Again, the reason I am doing chapter 3 before chapter 2. Okay. So delta n is 1 at n equals 0 and 0 otherwise. This of course means that if you have delta n minus 3, then it's 1 at n equals 3. Because n minus 3 you have to put 0 and you'll get n equal to 3. If it is delta n plus 3, then it is 1 at n equals minus 3. So it can be shifted, that's fine. Now let's say I have an input xn. Yes? That's it. And this input looks like this, that it has a 1 at 0 and it has a 2, let's say, at 1 and a 3 at 2. This is a discrete time signal. Normally for discrete times, when we do not draw something, what is it? 0. We only draw the non-zero values, yeah, unless the zeros fall between non-zero values, फिर वहाँ पे हम कुछ mark कर देते हैं, yeah. Otherwise we just skip the rest. Okay, so किसी को ये claim नजर आ रहा है? What is the claim? Firstly, let's say, what is a shifted delta? What is a shifted impulse? Plus. Yeah. So as I said, delta n minus 3, delta n plus 3, that's a shifted delta. Okay, shifted. What's the scaled delta function? Multiply. You multiply here by 4. What do you get here? Automatically you get 4. Why? Because this guy is going to give you 1 at n equals 0. 4 times 1 will be 4. So you will have, instead of a 1 at n equals 0, you will have a 4 at n equals 0. So what about this? 4 delta n minus 6. What do you get? So shifting and scaling. Shifting and scaling. So it is at n equals 6 and it has a scaling of 4. Yeah. So you can do shifting and scaling. Now what happens if you add this thing 4 delta n? कैसे लगेगा? ये दो values आ जाएंगी, right? So you will have one value here and one value here. What if I add another one? Let's say 2 delta n minus 3. How does the 2?
Add 3 2 लगा देंगे हम. 2 कर देंगे. 3 2 और 3 yes.
Yes. So you are making a discrete time signal here. Yeah. Now notice this. let's say I give you any discrete time signal xn. Now with this in your mind, can you help me write this as a sum of delta functions? Sum of scaled and shifted delta functions.
Yes, sir.
क्या होगा? पहला क्या है?
सर पहला वाला हमारे पास सिंपल वो है ना, क्या कहते हैं, n x n ठीक डेल्टा
No shifting, no scale.
सिंपल डेल्टा
Right? दूसरा क्या है? Sum shifting
2
n minus 2.
delta
n मल्टी
and
और 2 होगा
scaling
सर उसके साथ 2
plus
अगला 4 है, फिर 4 मल्टीप्लाई बाय डेल्टा और n minus 2 n minus 2
and it's 3. Yeah, scaling 3.
yes.
So what is this? A sum
Scaled and shifted
of scaled and shifted impulses. And notice any कोई भी आप मुझे दे दें, मैं उसका बना दूंगा. हो जाएगा ना, मुश्किल तो नहीं है. So the same thing actually you can do in the continuous, we will see, through an integral. Okay, and that is the power of the delta function. ये actually यही चीजें जो हमें काम आती है इसकी. But in discrete time it's very simple, it can be seen here. Now of course what we did was we just split this into 3 parts. We said okay, this guy is actually a sum of this plus 1 delta at of size 2, right? These two, if you add, I don't have space, so I'll just draw here, plus what's the third one?
3
3. So isn't this what you wrote? Yeah. So you are able to write any discrete time signal as a. Now also notice this. What is if I want to replace these by x now?
x
Xn.
simple
So what can I put here?
सर x से
X and or इसने x0 से वैल्यू उठाई थी ना आपने, without knowing it. आपने 2 कहाँ से उठाया था? x1, ये x है. Remember? This guy is xn. So you had actually intuitively picked up x1. Correspondence नजर आ रही है इसकी और इसकी. 0, 0 and minus 0, 1, 1 and
2
x 2. Yes. So then you have a general answer to. Basically, you can rewrite any signal xn as this thing. Now, how will this help us? That is where we will go now. Right. This was just an observation in the signals that is going to help us answer this question. So now we go to our question. What was the question? You have DT-LTI system. It's a black box. You don't know inside. You don't know its physics, chemistry, biology, economics, whatever. It's a black box. Yeah. You only know that it satisfies the property of being linear and time invariant. Notice when we checked LTI last lecture, we did not ask for the physics, the biology of the system, anything. Yeah, कुछ भी नहीं पूछा हमने. फिर कहा कि अगर ये भेजें ये हुआ, ये भेजें ये हुआ, फिर ये भेजें. Yeah. So the test was just observing here and here. That is called black box modeling. You're not opening this box. Yeah, and I've told you why. We do open the box in many problems, but then I've told you in many realistic problems, it becomes a headache to open the box and work with that. Yeah. So then, okay. Now let us start here. Let's say, I think I will need some space. Now I'm going to assume from now on that this is LTI, so I'll just write LTI here. Yeah. So I'm saying that I'm working with an LTI system just to emphasize. If I send in delta n, an impulse, yeah, I get a response. Let me give it a name. Yeah, I'll call it Hn. Yeah, this is the response to impulse. So from here on, we will call it impulse response. Make sense? logical and norm. Yeah, it's the response of the system to a simple impulse. Yeah, so the output, I don't know what the output is, but I'm just saying, let's say we call it HM. Okay, now if the system is LTI, what happens if I scale this input? If I say some value A naught, what should be the output?
सर A 0 H
Why?
क्योंकि ये सिस्टम पे परफॉर्म होगा
Yeah, because the system is linear and linearity includes homogeneity. So it is homogeneous. So I know now, if I know the output to the impulse, I know what the scaled output, the output will be to a scaled out impulse. Yeah. Okay. What happens if I give the system, let's say, not just scaled but also shifted input? What do I get?
सर वो भी स्केल हो जाएगा
बता दें आप क्या बनेंगे?
A1
A1
और मैं वो क्या डेल्टा सॉरी H और अंदर N भी हो जाएगा
agreed? Yes. So you scaled and shifted the input because of the LTI nature of the system. The output is scaled and shifted accordingly. Yeah, because it is LTI. Fine. What if I give a combination of these? So let's say I give it A0 delta n plus A1 delta n minus 1 goes to the LTI system. What should I get?
ये जाएगा A0 H
A0
H of N
h of n plus
A1 H of N minus 1
okay. Now let's see if this was just like we did before, let's say this was some generic input x0 and this was some generic input at x1, then what do you get here? x0 x1, agreed?
Yes.
Okay, now answer this one then. You have to, if I give it a generic input xk delta n minus k, what should I get? So this is for us a constant now, right? This is a value of the signal xn at time k. Yeah. So what is the output? You have h n minus k. Shifting leads to same shifting, yes, and scaling leads to same scaling, xk. This is what you have been telling me before, right?
Yes.
So xn is the function signal, xk is its value at point t n equals k. Yeah, so we constant value. What about this guy? If I give it, now I'm giving it a sum of these guys, right, over let's say some range of k or all k. What is this? It's saying, for example, x0 delta n plus x1 delta n minus 1 plus x2 delta n minus 2. So these are several terms. What should you expect here now? You have already seen this for two terms. Yeah, so it should be easy. So क्या होगा? Summation will be summation. Xk will be xk. Why? Because it's a scaling. It's the same scaling. What else?
H
H
N
n minus k. Now I showed you before when I wrote xn as a sum of scaled and shifted impulses. जो हमने पिछली example की थी ना, उसमें क्या लिखा था हमने? x0 delta n plus x1 delta n minus 1 plus x2 delta n minus 2, right? एक वो जो draw किया था हमने.
Yes.
So actually that was xn. Yeah. This is a general xn then, right?
Yes.
x0 delta n, x1 delta n minus 1, x2. अब अगर उसकी और values भी होती, वो भी इसमें आ जाती. So this is actually xn. isn't it? Yeah. So you just gave me the formula for the output. This is yn. Yes. So you have answered the question. What is the output of an arbitrary LTI system to any input xn? You say it is going to be this thing. Yeah, it's a special sum. Now, what do I need to solve this? ये आंसर इसको सॉल्व करने में मुझे क्या चाहिए? इनपुट आपको दिया हुआ है हमने, right? We said you will be told the input, whatever that is. xn will be given. What else do you need to solve this right hand side?
So why?
नहीं वो तो
सिस्टम
निकालना
का
है.
वो कैरेक्टरिस्टिक हमें पता होना चाहिए. System-
You have xn.
Yes, sir.
The whole signal is there.
Yes.
You are given. Do you have h? So the only thing you need is
System
h.
characteristics.
Yeah. What characteristic do you need? You only need one thing from the system. It's impulse response.
Oh.
Yeah, that's a very powerful result. All you need to do is to get the output of an LTI system to an arbitrary input is give the signal system a nudge. किया था ना हमने शुरू में delta.
कर सकते हैं.
Just give it a nudge, get the output, call that output nudge response or impulse response hn, and now because of this formula you can answer this question for any input. If you have h, yes, if you know the impulse response, just put that here. You will be given the input कि जी मैं sinusoid दे रहा हूँ, right? मैं unit step दे रहा हूँ input, मैं कोई और input दे रहा हूँ, pulses दे रहा हूँ. You put those here and you get this. So this is a very powerful result. And in fact, this kind of formula has a name. और आप वो नाम देख चुके हैं पहले briefly. Yes? जब हमने डबल शाह और वो क्वाड्रुपल शाह का किया था ना.
Yes.
एक मैंने ऑपरेशन आपको बताया था vocabulary में. You will be using like plus, minus, so on. In signals and systems, there is a very special operation which is very, very key to all of signal system. Convolution. इस फॉर्मूले को हम कहते हैं, शोकिया नहीं बनाया ये जो convolution का फॉर्मूला है ना. It hasn't been made like out of interest. This is called xn convolved with hn. This is how we defined. Okay, for any two functions, convolution is defined like this. And why do we use this definition? You have the answer here. Because this definition is the answer to our question. What was the question? What is the output of an arbitrary LTI system to an arbitrary input? So the answer now is, it is the convolution of the impulse response with the input. Okay. So you tell me the input. What I'll do is I'll send an impulse to the system, get its impulse response, which will be hn. I will convolve hn with xn, whatever input you gave me, and that will be out. Yeah. A very general solution. So only one thing. आपने ये नहीं देखना कि वो system अंदर से. First you have established that it's LTI. This will not work if the system is not LTI. Yes. Okay, you use the properties of LTI to get here. So if you have established that system is LTI, you don't need to bother about कि वो उसकी equations कितनी है, physics की, biology की, उसके अंदर क्या क्या हो रहा है, right? All you need to do, send it an impulse, see how it responds to an impulse. Call that HN, an impulse response. Yeah, call that, and convolve your whatever input you give me now. I will convolve that input. By convolution we mean I will perform this operation, this tedious operation. It's like a summation and shifting, and it's done over k. Yeah. So what is the two key takeaways from here?
सर ये आपने समेशन के नीचे k के साथ क्या लगाया हुआ है?
Oh, for all.
For all.
मैथ में जो नहीं इससे होता है ये सब. for all sorry आप नहीं use करते अब कर लें ठीक for all k because I don't know what k's are here you know k is 0 1 2 3 discrete time है ना k could be 2 3 6 7 non uniform distribution हो सकती है sampling so we just say for all k wherever it's applicable yeah so right so two important takeaways from here is this are these that to fully characterize LTI or to understand the output of LTI systems you need to be familiar with the concept of impulse response and convolution. Yes, because the output is the convolution of the impulse response with the input. Okay, so you should be intimately familiar with convolution and impulse response, and that is the direction of our future few lectures. Yeah, so दो जो की कॉन्सेप्ट निकले हैं इधर से क्या क्या हैं एक है जी कॉन्वोल्यूशन ये क्या बला है और दूसरा इम्पल्स रिस्पॉन्स टू go into the details of these yeah convolution का मैंने आपको थोड़ा सा आइडिया पहले दिया था briefly yeah but we will do that in more detail this time that was just to get things started so let's see first let's define now so first we'll spend some time on this guy ये इस बार इस ये जो भी बोर्ड पे लिखा हुआ है ना let's say फोरियर ट्रांसफॉर्म आगे आएगा या वो लाप्लास कोई भी एक ट्रांसफॉर्म हम करेंगे ना बिफोर दैट उस वो एक और डोमेन है उसमें सबसे अहम फॉर्मूले आएंगे बट in the time domain thing this is the most important writing in this field इसी पे सब कुछ build है even आपके जो neural networks का concepts है ना most of them are built on something from here okay so इस screen को इसको board को ये आपको समझना चाहिए it's not too hard to understand yeah but any questions इसमें
सर ये बायन के नीचे आपने जो लिखा हुआ है कि एक्स एन कॉन्वोल्यूटेड विद एच एन इक्वल टू के ऊपर ट्रायंगल लिखा है इसका मतलब
ओके या देखिए इक्वालिटी मींस थिंग्स आर इक्वल 2 + 2 = 4 yes but let's say I want to say 2 + 2 = c does that make sense you can only define 2 + 2 to be a variable c ऐसा ही है ना तो मैथमेटिकली जो प्रॉपर मैथमेटिक्स है दैट सेज दीज आर नॉट इक्वल बाय एनी स्टैंडर्ड 2 + 2 इज इक्वल टू 4 यस बट ये और ये तो इक्वल नहीं है ये तो मैंने एक ऑपरेशन डिफाइन किया है राइट सो इट्स कॉल्ड दिस इज रेड एज डिफाइंड एज इसको डेफिनेशन कहते हैं इसको ठीक तो ऐसे मैथ के सिंपल बार रिवाइज कर ले या ठीक है और नहीं है कि कैरेक्टर्स वगैरह में नहीं पाया आपको अच्छा खुद ही एक प्रिंट निकाले मजे के होते हैं देयरफॉर तो याद है देयरफॉर बिकॉज़
देयरफॉर ये सब एक केवल है वो एक ई वाला
वो एक आता है आई डोंट नो आप में से सिटकॉम्स के कितने फैन हैं पर ये वाला एक मीम आता है अब इसके लिए आपको सिटकॉम्स का भी फैन हो
बी
सॉरी बी रह गया हां I'll be
there for you
yeah
yes
फ्रेंड्स का जो सॉन्ग है राइट सो ऑफ कोर्स देयरफॉर बिकॉज़ वो तो इजी है बिकॉज़ इसका उल्टा होता है या दिस इज फॉर ऑल ये वाला वी में से कट करते हैं दिस इज डिफाइंड एज ओके इक्विवेलेंट का 3 लाइनें होती हैं
yes
वो भी आप पता होगा कहीं ज्योमेट्री में पढ़ा होगा बट नो बिग डील इट्स गुड टू आस्क रिमेंबर कोई मसला नहीं अगर आप भूल चुके हैं आप ठीक है आप वो यूज नहीं करते होंगे यू कैन आस्क बट इफ यू डोंट आस्क एंड एक्चुअली आई डिडंट थिंक ऑफ टेलिंग यू बिकॉज मेरे ज़हन में नहीं था कि भूल गए लेकिन नो प्रॉब्लम नाउ यू आस्क नाउ यू नो राइट दोबारा रिफ्रेश हो गया ठीक है सो perfectly fine to ask yeah so we're saying this operation from here on we will define it as a convolution that's all yeah okay और कुछ है इसमें नहीं है right so it's a long word way of saying that Usually people teach it like this, that the output of an LTI system to an input is the convolution of the input and the impulse, right? But इसके पीछे क्या story है, where did it come from, पूरा वो आपको वो पता होना चाहिए सारा कुछ, right? कि how do we develop this? And that brings good motivation for understanding convolution and impulse response, because they are very powerful tools to work with LTI systems. So let's first of all define convolution. So from here on we will say, पहले मैं दो general functions की लिखता हूँ, फिर हम input output की लिख देंगे. So in discrete time, let's say you have a function fn and you have a function gn. Yeah. So the convolution of fn and gn is defined as summation f k g n minus k over all k wherever these guys exist. Now वो depend करता है इनकी range क्या है. This is a definition, okay, of convolution. Okay. Where was this motivated from? शौकिया नहीं ये बनाया हमने. This was the result you got when you sent in an arbitrary input, which was what? A sum of scaled and shifted impulses. So the output had to be a sum of scaled and shifted original outputs, right? Impulse responses. So this whole thing is motivated by that definition or that result. So from here on, this is what we will call, this is the definition of convolution. When we go to chapter 2, back to chapter 2, we'll redefine it in a continuous case. This will become integral. Okay, कोई और बड़ा कमाल नहीं होगा इसमें, right? So we'll see that afterwards. Okay, this is convolution. Now a few properties of convolution that may be helpful. Firstly, convolution is commutative. Okay, so in terms of our input and output, like we like to write in xn is the input, hn is the impulse response, then what is the convolution of these two? Now we have defined it, so we will just use it. What is it? क्या बनेगी?
x k or h n minus k.
Right, or all k. So this is now going, this is general mathematics notation, f, g, f and g functions. This is our notation where the input is a function and the impulse response is a function, and you have this. Okay, so firstly it is commutative, which means that x n, क्या होता है commutative में? Is addition commutative or not? है?
Additive.
नहीं, commutative क्या होता है? पढ़ेगी यार, मैट्रिक एफएस
एलिमेंट्री मैथ कांसेप्ट्स हैं
है? क्या होता है? डिवीजन कम्यूटेटिव है या नहीं? हाँ. Yes, this is the commutative property. Division में ये fail हो जाती है, right? Subtraction में भी ये fail हो जाती है. For convolution, you can prove that they are actually commutative. So xn commuted with hn is the same as hn commuted with xn. Okay, what does that mean for this formula? क्या बनेगा अगर मैं राइट हैंड साइड को अब लिखूं?
रूटा करने से h करने
h k
और फिर x k minus 1 n minus 6
k for all k. That means these two are also equal then. Yeah. So actually it doesn't matter कि आप किस फंक्शन को डिले करते हैं और किसको फिक्स रखते हैं. Okay, f को या g को. If you switch roles, you still get the same answer. या आप simply करके देख सकते हैं, उसमें मुश्किल प्रूफ नहीं है इसका. Commutative property. Okay, so convolution is commutative. Good. Second, you know what's the identity of an operator in mathematics? Addition की identity क्या है? Zero. क्या होता है identity? So how do you say it? A plus identity equals A. वो ऑपरेटर अगर अप्लाई करें उसके साथ और वो वापस आ जाए, कुछ भी ना चेंज हो, तो उसको आइडेंटिटी करें। तो मैं इसके आइडेंटिटी क्या है, 0। प्रोडक्ट की क्या आइडेंटिटी, 1, बिकॉज यू हैव टू सी a times I equals a. Yes, so what is that I which qualifies? So convolution की आइडेंटिटी फिर क्या होगी, xn convolve with something gives back xn. या तो कोई गैस कर सकता है क्या होगी, 1 year. से जी
सर क्या चीज़ है, रिपीट करें क्वेश्चन।
So xn convolve with what will lead back to xn. If we have something like that, we will call it the identity of convolution. Identity का तो concept याद है ना, समझ आ गई है। Imagine here, if you have xk, yes, किसी ने कहा कि 1 है identity. If you put a 1 here, constant है 1, ठीक है, doesn't shift. You will be summing all the x, right? You won't get xn back then, है ना? आपको तो xn चाहिए, कैसे निकालेंगे?
नहीं सेम स्क्वायर में
कुछ करना पड़ेगा।
एक्सपोनेंशियल 0 कर।
Okay, I'll help you out. Just put a delta n minus k here and see what you get. करके देखिए जल्दी से, करके सॉल्व करें। अगर जहाँ पे delta n minus k हो, तो you have x k delta n minus k summation over k.
कोई आंसर आते हैं
क्या आएगा?
x
So n equals k पे, when k is 0, you will get, ये terms है ना, so you will get x0 delta n. When k is 1, you will get x1 delta n minus 1. तो इसको प्लॉट करें, ये बता रहा है कि at 0 प्लॉट x0, at 1 प्लॉट x1, ये तो xn का प्लॉट आ जाएगा दोबारा से, ये तो सिर्फ जगह का बता रहे हैं, होते में कुछ नहीं करना। Yes, so you get back xn. So what's the identity of convolution? Delta function is the identity of convolution. What does that mean? A function convolved with impulse or delta comes back itself.
सर ये समझाना प्रॉपर्टी रिपीट करें।
So we are saying xn convoluted, any arbitrary signal convoluted with the delta function gives back the same signal. Yeah. और वो यहाँ से आपको समझ आ जाएगा, अगर you just put delta n minus k here, that would be xn convolved with delta n. But if you try to solve this, you find that it actually expands into these terms. But this can be shown, we have already discussed this, this is actually xn. Why is it xn? It's exactly giving you the value. Yeah. So suppose you want x0 from here. Put n equal to 0. What you get? x0 delta 0, x1 delta minus 1. So these all the other terms disappear. 0 होगी ना? Only this term remains. This is 1, so you get x0. If you want x1 from here, put n equal to 1. When you put n equal to 1, this becomes 0. This becomes 1. You get x1. All the other terms also become 0. You get x1. So your left hand side is perfectly capable of giving you the right hand side anytime you want. Yeah. So xn convolved with delta n from here also over here. So it's commutative, its identity exists, and the identity is delta n. Okay. Then it's also distributive, associative. पता है, याद है distributive, associative? क्या होती है?
Associative A plus B.
A times B plus C, for example, ये distributive चला है. क्या था वो? A B plus A C. ऐसे ही था ना? So in convolution also you have this thing that if you are convolving x1n with a sum of x2n plus x3n, it simply distributes to become x1n convolved with x2n plus x1n convolved with x3n. Yeah, this thing. एसोसिएटिव बता रहे थे आपने, वो क्या होती थी? प्रोडक्ट की एसोसिएटिव प्रॉपर्टी है कि a times b c is a b and it doesn't matter which one you do first. Yeah, so same is for convolution. Okay, if you have three functions being convolved, पहले दो को करें जो आपको उससे करें, या दूसरे दो को पहले करें और जो आपको पहले से करें, same solution. Yeah, so it is also associative. Okay, now how do we solve convolutions? क्योंकि फॉर्मूला थोड़ा सा टेढ़ा मेढ़ा सा है, so how do we solve?
फिर ये डिस्क्रीट में हम करेंगे ना फॉर नाउ कन्वोल्यूशंस को सॉल्व.
हाँ,
डिस्क्रीट टाइम सिग्नल्स में करेंगे कन्वोल्यूशन को सॉल्व फॉर नाउ.
for now, हाँ, chapter 3 में, but we will come to chapter 2 where we will also do it in the continuous time. You will have integrals. Yeah, but again from exam point of view आपको कोई ऐसे integrals वगैरह नहीं मिलेंगे जो you have to solve long things. Yeah, but here I want to develop the concept. So how do we solve convolutions then? अब देखें, we have an LTI system and let's say I know its impulse response, and then you give me some generic input and you ask me what is the output. Yeah, by now I know, okay, it is simply convolution of these two guys. Yes, that's all. So then I should be able to solve this. You will be coming across this very often. Convolution बहुत आता है systems में, बार बार करना पड़ता है क्योंकि that is the output. Yeah, so then how do we actually solve convolution? Well, it's kind of like integrals. Actually आप जब continuous में देखेंगे तो convolution of ft with gt will actually be an integral minus infinity to infinity f of tau gt minus tau d tau. Yeah, so अभी हम उसको discrete में कर रहे हैं which is leading to summations, so that is also problematic. So actually the most common way we do it is on computers. आप lab में क्या use कर रहे हैं? MATLAB. Yeah, so that is the most common way actually. मैं हाथ से नहीं करता convolution. We will make you do some in the quiz or exam or assignment just so you learn the idea convolution होती क्या है, right? Otherwise उसके बाद we just hand it over to computers. Another way of doing it, ये आप इंटीग्रेशन वगैरह भी बहुत सी न्यूमेरिकली या जैसे भी करते हैं. इंटीग्रेशन एक और तरीके से भी आप करते हैं और वो यहाँ भी यूज होती है बाय टेबल्स प्लस प्रॉपर्टीज. इंटीग्रल के टेबल होते हैं ना, डेरिवेटिव के भी होते हैं, फिर प्रॉपर्टीज होती हैं कुछ कि ये लीनियर है ये नहीं है. प्रॉपर्टीज अभी मैंने चंद आपको बताई हैं, इस तरह कई हैं. कॉन्वोल्यूशन की शिफ्टिंग प्रॉपर्टी है, द वंस आई जस्ट टोल्ड यू आर कम्यूटेटिव, एसोसिएटिव, डिस्ट्रीब्यूटिव, राइट, and the identity is delta n. So that's another way. A third way which we love to give to students, which is इसकी words mostly educational है, you know, pedagogy का मतलब use नहीं करते. Once you do it graphically ना तो एक बड़ा अच्छा image बनता है. We will do that. Yeah, but I'm just giving you the whole idea, whole picture of how we really do this thing. So computing most common, yes, by table and properties if you just wanted to do analytical. और analytical करनी पड़ती है कई दफ़ा. You have something you're dealing with which is a cascade of many systems. हर एक उनमें से LTI है, आपने solve करना है. You may not be able to give this to a computer. Okay, पहले आप उसको analytically solve करेंगे खुद से. That is where this guy comes in handy. But anyway, the third one is by graphically, and in that the most two common ways are plots and sliding tape. Sliding tape मैंने थोड़ा सा किया था, दोबारा हम करेंगे जब हमने वो quadruple shaw का केस डिस्कस किया था ना. Briefly did it. You give 2 rupees on Tuesday, 2 rupees on Wednesday. याद है वो slide हो रहा था, फिर वो add हो रहा था वो. So we will do that. So let's see each of these very briefly, yeah, and then we'll end the lecture for today. आपको एंडिंग का जो है ना वो अंदिया देना पड़ता है वरना आप परेशान हो will it ever end? Yeah. Okay. So MATLAB. Let's say in MATLAB, if I have, often you write processes as vectors. So let's say the input is written as this. Basically, मेरे पास एक input है which is -1 at 0, and then it's 0 and then 1. Let's say yeah. So usually you feed vectors into MATLAB. This is the input, and I give you the impulse response as 0, 1, 0. Then in MATLAB you want to find the output. Why? You will say it is conv, built-in command है. अभी तक use कर लिया या अभी नहीं की? करनी आ गई. So you do convolution x with h, और MATLAB आप उसका जवाब दे देगा. कोई फॉर्मूला लगा के जो भी है. Yeah. So this is simple MATLAB. That's done. How do we do it? By tables and properties. Let's say we have I want to solve this convolution. Un convolve with delta n plus 5 un. Let's say I want to do this. Okay. Now your book has the table. Yeah. Exam may I give you the table also. But as you know very well from integrals and derivatives, just having the table does not answer the question, right? Usually उसकी juggling करनी पड़ती है ना. अगर सिर्फ टेबल पढ़ना हो तो हम आपकी आंखें तो चेक नहीं कर रहे. वो भी कर सकते हैं, लेकिन we're not checking your eyesight. Yeah, we are testing if you can use that in a slightly bigger problem. So इसी तरह इसके भी tables हैं. I'll give you the tables, but if you don't practice through assignments, through solving problems, through quizzes, then you will have trouble. So now let's try this one. Table तो भी मैंने उसमें book में आप देख सकते हैं, लेकिन property कौन सी use हो सकती है यहाँ पे to make it simpler? Distributive. Yeah. So we could do this. We could say okay, un convolve with delta n plus un convolve with 5 un. What is this? Quick thinkers.
ये प्रॉपर्टी बन गई हमारे पास.
हाँ, कौन सी?
सेकंड वाली आइडेंटिटी.
क्या आएगा ये?
So ये UN ही आ रहा है.
UN. So you use the property again, another property. Yeah. But now here you are stuck. UN convolve with UN. अब आप या तो वो पूरा करके निकालें, लेकिन luckily tables में पड़ा हुआ है वो. ठीक है? And it's actually UN convolved with UN is n plus 1 times UN. जैसे आपके पास x n का इंटीग्रल क्या होता है? x n plus 1 over n plus 1 unless
n is -1 is
हाँ,
minus
right? Because उस पे फिर वो
नहीं
मसला हाँ. So similarly you are in the table you have this one table लिखा होगा, उसमें लिखा होगा कि un convolve with un is actually is it n plus 1? मुझे भी याद नहीं होता वैसे. n plus 1 times un, n plus 1 times un. So just use that. So you say 5 times n plus 1 times un, and now you got a solution to this. Final आगे convolution खत्म हो गई. You did all the convolution. Yeah. So that is the second method. Yeah. Then the third method. बस कर दूं. थर्ड मेथड तालिन दे यार, कॉन्वर्सेशन खत्म हो जाएगी. बहुत फास्ट है, आपने ऑलरेडी किया हुआ है. ब्रीफ हाँ, ग्राफिक की बात. एक विल डू वन ओनली. So then next lecture we will move to the second important takeaway, which was impulse response. Convolution and impulse response निकले थे ना आज के दो main
आपने assignment भेजी लेकिन हमने किया ही नहीं.
क्या हो गया?
जो आपने assignment भेजी है सर.
तो अभी शुरू किया ना impulse response के सवाल.
हाँ हाँ, पर आपने कर लिया
मिड तक कॉन्वोल्यूशन ठीक नहीं है.
है?
मिड तक कॉन्वोल्यूशन ठीक नहीं.
वो भी डिसाइड करते हैं ना, ये तो करेंगे. नेक्स्ट वीक है मिड. डेट शीट आ गई.
आई तो नहीं
उससे लेट नहीं हो सकता.
चलें देखता हूँ.
उम्मीद तो नेक्स्ट वीक है सर.
So let's see, let's do this very quickly. The last method, so I'm done with it. You have LTI system. So it has some impulse response hn, and you have to find yn. What's the graphical method? Okay, so let's say the input is this. Xn is 40, 30, 20, 10. 40, 30, 20, 10, and this is at 0, 1, 2, 3. This is your xn. Okay?
Yes.
What else you need to solve this? By now you know, since it's LTI, so the answer has to be xn convolved with hn. Yeah? So then you also need the hn. How you get it, we'll discuss it later. Or as I said, just send an impulse and see what's the output. That will be your impulse response. Let's say this is the impulse response. Next lecture we will see a full interpretation of this. अभी नहीं, अभी सिर्फ हम convolution को देखें. Yeah. So 10 and 5. Let's say this is hn.
जो सिस्टम काम कर रहे हैं,
हाँ.
linear time invariant system, वो ये काम कर रहे हैं.
उसका ये impulse response है. Meaning if you give it one impulse only of unit size, single delta n, it gives you this outcome. Okay, that's what you need. hn. Yeah. Then you will convolve the two to get yn. MATLAB पे मैंने आपको दिखा दिया. You just put x equals 40, 30, 20, 10, y and h equals x this, h this, and conv, and you'll get done. Yeah. Now we want to do it graphically. Yeah. So to do it graphically, what will help us is this thing. Yeah, I'll skip the equations, but I'll show you this thing. What we do is first write these. We'll do only one of those that's called the sliding tape method. Okay. What it does is it writes the xn and the hn on tapes. Yeah. So what is xn, which is 40, 30, 20, 10, and you draw an arrow to show that this is where the 0 is. Tape में तो नजर नहीं आ रहा ना?
Yes.
Okay. hn क्या है? 5, 10,
arrow rate.
5. Or either this is 0. Okay. First you write them this way. Okay. Then what you do is this. You flip one of them. Okay. Let's say we flip the input, which is more common. So you will flip the input ऐसे.
Minus x
ठीक है,
minus
हाँ.
m.
क्यों था वो? अगर आपको याद हो, one of these is saying, if one of the definitions says there is hk x n minus k, yeah, overall k. So you need to somehow flip it. Yeah, there is a flipping involved in there. एक को करना है क्योंकि commutative है, won't matter किसको करेंगे, but it's more instructive to flip this guy. So I'm gonna flip it, and now it is ऐसे हो गया. Yes. Leave the other one as it is and align them at 0. ये बहुत important है. इसका 0 ये है ना. And don't flip the other one. 5, 10, 5, and make sure that these arrows are aligned. Okay, that's where the thing starts. Okay, now remove the arrows. Okay, this thing, when you just align them first time, whatever they are, multiply these. Okay, what is that? 5 times 40. Yeah,
200.
is 200. This will be the first value, the 0th value, when you align them at 0 and you just start it. Yeah, so क्या किया था? एक को flip किया, okay, and you align them at 0. This one. Now what you do? Push this guy one step forward.
सबको multiply
So
करते हैं.
एक step forward से क्या होगा?
y1 की वजह से.
So you will have it somewhere
50.
like this. Yes, 40 is now here, 30 is here, 20 is here, and 10 is here. Yes, so you since pushed it one step forward, which will be actually y1. ये किसी को ख्वाब नहीं आया था, ये उस फॉर्मूले से निकल रहा है actually. I can show you where it's coming from. This formula, hk x n minus k over all k. ये जो definition है ना convolution की. There is a flip, and then to get y0, don't shift. Yeah, flip था सिर्फ. To get y1, flip and shift by 1. ये सारा यहाँ से निकला है, लेकिन अब आपको मैं सिर्फ एक graphical summary वो नहीं था rule of thumb type वो बता रहा हूँ. Now this will be y1 because you shifted by 1, and now what you do is see the overlapping cells. Okay, 5 times 30 plus 10 times 40 है जो भी आता है. अगला क्या स्टेप है समझ आ गया होगा आपको? एक और वो y1 होगा, फिर एक और y2 होगा. कब तक जाएंगे?
जब तक वो निकल नहीं जाता नीचे.
एग्जैक्टली, ओवरलैप खत्म नहीं हो जाता. राइट, जब फाइनल यहाँ पे ये लुक ऐसी होगी इसकी, यहाँ 10 होगा, यहाँ 20 होगा, यहाँ 30 होगा, यहाँ 40 होगा. whatever number you get to, that will be this thing. Yeah, इस केस में you can also shift to the left in signals. Yeah, but in this case I am not doing it because I know it will be 0. y minus 1 will be 0 क्योंकि वो already overlap खत्म हो जाएगा. Yeah, but here you keep on going until you get here. This will be the last value whatever you get, 5 times 10. उसके बाद से overlap फिर खत्म हो जाएगा. That is your graphical output of the convolution. Right? अब just one question from you guys. समझ तो ये आ गया होगा आपको. या can you tell me why does the flipping this, let's say this, why does it make sense? मैथमेटिकली तो नज़र आ रहा है. या कोई आपको इसकी फिजिकल सिस्टम के पॉइंट ऑफ व्यू से, रिमेंबर दिस इज व्हाट्स हैपनिंग. xn is here, yes, hn is what the system does to you, and this is yn. Yeah, why does this flipping make sense? This is your input. So firstly let me show you what's happening here quickly. Yeah, what are you doing here? You're saying my input, this guy, is going to go through the system. यही होना है ना. Now as it enters the system will do something to it, and that will make the first response. Yes, then this input will go further in. Yeah, so the whole input will pass through the system and you will keep getting outputs. Those are y0, y1 and 2. Yeah, so it's very nice to see this sliding. Actually this is your input going through the system. Once it's out of the system you start getting zeros again. Yeah, so why the flip then?
सिर्फ सिर्फ बाय द फ्लिप ना, अगर आप देखें कि हम उसको फ्लिप ना करें, हमने एट द एंड सारी सबमिशन करके हमने हर वैल्यू को हर इटरेशन में मतलब हर किसी से मल्टीप्लाई करके सबको ऐड ही कर देना. क्यों कर रहे हैं फ्लिप?
Because if you don't, you will get these wrong values. वही आएंगी, लेकिन you will be saying that y0 क्या होगा, फ्लिप किए बगैर आपका y0 क्या होगा, 10 times 5 होगा. आउटपुट की असाइनमेंट गलत हो जाएगी. ऐसे ही है ना. सो वो आपकी बात ठीक है कि वो सारे एक्चुअल वैल्यूज वही रहेंगी. 200 भी आएगा किसी वक्त.
अच्छा, इस केस में क्योंकि फाइव आगे भी है. अच्छा सही,
ठीक.
इस केस में सेम रहेगी.
अच्छा, लेकिन फ्लिप का चले मैं आपको आइडिया दे सकता हूँ. दिस इज द इनपुट दैट इज गोना गो थ्रू द सिस्टम. राइट, मुझे ये बता दें कि इनमें से कौन सा इनपुट के कई है ना, इनपुट के कई वैल्यूज है ना. याद है वो क्वाड्रपल शा को 2 rupees ऑन ट्यूसडे एंड 2 rupees ऑन वेडनेसडे दिए थे ना. सो दिस इज इट. व्हिच ऑफ दीज विल एक्चुअली एंटर द सिस्टम फर्स्ट? 40 और 10. कौन सा होगा? 40 पहले होगा. राइट, सो this input occurs after this one. तो सिग्नल जो हम ड्रॉ करते हैं ना, एक्चुअली वो हम गलत ड्रॉ या इन अ वे उल्टा ड्रॉ हो रहा होता है. उसकी जनरेशन एक्चुअली फ्लिप ही होती है. this was generated by you at x0 and this was generated by you at x3 later. Yeah, so अभी जब वो जनरेट ही नहीं हुआ तो उसको पहले क्यों भेजेंगे अगर? Yeah, so the flip not only makes sense from the math, it actually makes physical sense also. This signal is actually going to enter the system like that. पहले 40 जनरेट होगा, वो गुजरेगा. 30 जनरेट होगा, वो एंटर होगा. 20 जनरेट. और if you remember in the case of quadruple SHA, मसला क्या हुआ था कि एक ट्यूसडे और वेडनेसडे को आपने 2-2 रुपए दिए थे, राइट? एंड ही सेड आई विल गिव यू 2 rupees the next same day and 2 rupees after that. तो जब आपने 2 दिन के दिए तो वो ओवरलैप करना शुरू हो गए थे. आउटपुट्स, अगर आप वो स्लाइड्स देखें दोबारा से. So this is what's going to happen. The output of this is going to lead to 3 outputs. एक पिंग मारेंगे आप, 3 जवाब आएंगे आप, ठीक है. That simple is response. अब अभी वो पूरे हुए नहीं होंगे कि आप दूसरी पिंग मार देंगे तो ओवरलैप आना शुरू हो जाएगा, क्योंकि उसको भी 3 जवाब मिल रहे हैं. फिर आप तीसरी पिंग मारेंगे, उसको भी 3 जवाब मिल रहे हैं. तो जब वो ओवरलैप होना शुरू हो जाएंगे, प्रॉब्लम्स बनना शुरू हो जाएंगे, सिंपल एडिशन वोंट वर्क. सो दिस इज व्हाट यू आर एक्चुअली डूइंग. यू आर चेकिंग कहाँ कहाँ ओवरलैप होना है और उसका क्या जवाब आना है, ठीक है. सो विद दैट वी एंड द लेक्चर. कोई क्विक क्वेश्चन?